All right, so get this. You sent us some research, and it's about galaxies that just stop making stars.
Yeah.
Galaxy quenching, right? And it's like, I don't know, it's like this cosmic mystery, and
Yeah.
we're trying to figure out what's hitting the off switch on star formation.
Yeah, you've got a fascinating lead to follow.
Okay.
This paper suggests that something called astrophysical black holes, or ABHs, might be responsible.
ABHs.
Yeah.
I'm intrigued, but also kind of lost. I
Mm.
thought I knew black holes.
Okay.
They're super dense things that gobble up everything,
Yeah.
even light.
Yeah.
So what makes these ABHs different?
Well, that's the mind-bending part.
Okay.
ABHs supposedly don't have an event horizon.
Wait, the black hole without the black hole part.
That's right.
How does that even work?
It's what makes them so intriguing
Okay.
and potentially game-changing for this whole galaxy quenching mystery.
Right.
Imagine a black hole where matter can fall even closer to the singularity at the core. The energy and heat generated would be off the charts.
Okay. I'm starting to see why this could be a big deal.
Yeah.
So you're saying these ABHs could be like these cosmic furnaces.
Right.
Blasting out so much energy, they heat up the surrounding gas,
Uh-huh.
and then that gas can't cool down to form new stars.
Exactly.
So it's like trying to make ice in a sauna.
Yeah. Yeah, good analogy.
The environment's just too hot for things to settle and come together.
That's right.
But wait, don't we already have some ideas about what causes galaxy quenching?
Yeah.
Like those supermassive black holes at the centers of galaxies?
Right.
I mean, we've talked about those.
Yeah. So we used to think that those supermassive black holes were the main suspects
Uh-huh.
that blast out energy as they feast on surrounding matter.
Right.
But this new ABH theory
Yeah.
suggests they might not be acting alone, or maybe they're not even the primary culprit at all.
So ABHs could be like, what, a silent assassin? They're just quietly shutting down galaxies without the dramatic fireworks we'd expect from those supermassive black holes.
Yeah, that's a good way to put it.
Yeah, that's kind of spooky.
It is, yeah.
But before we get too deep into how ABHs would do it,
Sure.
what's the evidence that galaxies are being quenched in the first place?
Oh, well, that's where things get even more interesting.
Okay.
The James Webb Space Telescope has been finding these quenched galaxies way earlier in the universe's history than we thought possible. We're talking about galaxies that stopped forming stars when the universe was barely 1 billion years old.
It's like finding a ghost town in the Wild West, abandoned way before it should have been.
Right, yeah.
That throws a real wrench into our understanding of how galaxies evolve, right?
Absolutely. It's incredibly hard to explain with our current theories.
So that's why these ABHs are such an exciting lead.
They could be, yeah.
They might provide that missing piece of the puzzle.
Exactly.
Okay, I'm definitely hooked.
Good.
So how would these ABHs cause this early quenching? The paper you sent talks about both long-term and short-term quenching.
That's right. So the long-term quenching scenario,
Yeah.
it involves those supermassive ABHs that might lurk at the centers of galaxies.
Okay.
Now, because matter can fall closer to the singularity in an ABH,
Uh-huh.
it creates a much more powerful accretion disk.
So you're saying these ABH accretion disks are like supercharged versions of the ones we see around regular black holes?
That's a good way to think about it, yeah. And this leads to a really dramatic difference in how much energy they pump out.
Oh, wow.
The paper actually shows some graphs comparing the luminosity or brightness of ABHs in traditional black holes,
Uh-huh.
and the difference is stark. ABHs are radiating way more energy.
And that extra energy is what's heating up the gas and preventing those baby stars from forming.
That's right.
It's like they're cranking up the thermostat on the entire galaxy.
I like that, yeah. A very apt analogy.
Okay, so we talked about the supermassive ones,
Right.
but the paper also proposes that smaller stellar mass ABHs could be causing these short bursts of quenching that we see in some galaxies.
That's right.
Okay, so now we're talking about two different scales of ABH action.
Yeah.
The supermassive ones at galactic centers,
Uh-huh.
and these smaller ones may be forming when really massive stars collapse.
Precisely.
It's a multi-level explanation.
Yeah.
And it gets even more intriguing when you consider what might happen during the formation of a stellar mass ABH.
Right.
Okay, you've got to tell me more. What
Right.
could possibly make this even weirder?
All right, so imagine this.
Okay.
A massive star collapses,
Okay.
and for a fleeting moment, before the event horizon has a chance to form,
Mm-hmm.
we might actually see the singularity itself.
Hold on. You're saying we might catch a glimpse of what's essentially the naked core of a black hole before it gets covered up?
Yes.
That seems impossible.
It is a mind-blowing idea.
It is.
We need a better grasp of quantum gravity to fully understand it. But if these naked singularities exist, even for a tiny fraction of a second, they could release an unimaginable amount of energy.
So these naked singularity events could be like cosmic flashbangs, blasting out so much energy they temporarily shut down star formation in their vicinity.
That's the hypothesis.
Whoa.
And it could explain some of the short-term quenching episodes we see in galaxies.
Just thinking about that makes my head spin.
Yeah.
It's almost too incredible to believe.
I know.
But this paper is suggesting we might already have observational hints of these ABHs in action, right?
Yes, and that's what we'll explore next.
Okay.
We'll dive into the evidence from those powerful winds with their unusual magnetic fields to observations of our very own galactic center.
All right, let's get to it.
Okay.
Okay, so before we got sidetracked, we were talking about ABHs and this mind-blowing idea
Right.
that we might be able to see a naked singularity,
Yeah.
the core of a black hole,
Yeah.
exposed.
It's pretty wild.
It's almost too crazy to believe. But the paper you sent dives into some tantalizing clues that suggest these ABHs
Yeah.
might be more than just a theory.
Right. It connects them to some intriguing real-world observations.
Oh, right.
One of the biggest clues comes from those powerful winds we see blasting out of some galaxies.
Hold on.
Yeah.
We were just talking about how ABHs quench galaxies, and now they're causing these powerful outflows.
It's all connected.
Okay, so it's like these ABHs can flip a switch,
Yeah.
going from silent quenchers to these cosmic wind machines.
Think of it like this.
Okay.
What if these winds, with their intense magnetic fields,
Yeah.
are a sign of an ABH transforming into a traditional black hole?
Okay, now my head is really spinning.
I know, it's wild.
So you're saying an ABH might exist for a while,
Right.
blasting out these wild winds,
Yeah.
and then it settles down,
Yeah.
forms an event horizon,
Yeah.
and becomes a regular black hole.
It's like a cosmic metamorphosis.
A very poetic way to put it.
And the paper points to some specific observations that support this idea.
Okay.
They highlight these winds with incredibly strong magnetic fields,
Yeah.
way stronger than anything we'd expect from normal stellar activity.
Uh-huh. So these winds are so powerful, it'd be like
Yeah.
comparing a gentle breeze to a raging hurricane.
Yeah, that's a good analogy.
And that power, you're saying, is a calling card of an ABH in action.
Precisely.
Like a cosmic smoke signal saying, hey, something really strange is happening here.
Exactly.
But to really appreciate how revolutionary this ABH idea is,
Yeah.
we need to compare it to the more established theories about what causes galaxy quenching, right? We talked earlier about those supermassive black holes
Right?
at the centers of galaxies.
Uh-huh.
We know they can blast out energy as they devour matter.
Yeah.
It's called AGN feedback.
Exactly.
AGN stands for active galactic nucleus.
Right. And it's basically a supermassive black hole having a cosmic feast.
That's one way to put it.
But these feasts can get messy.
Releasing huge amounts of energy that can heat up and blow away gas, disrupting star formation.
Exactly.
So for a long time, we thought these AGN were the main culprits behind galaxy quenching.
Right.
But now, ABHs are entering the scene, and they might be even more efficient at turning off the star-making machine.
That's the key insight from this paper.
Okay.
It all comes down to efficiency.
Efficiency.
How effectively a black hole or an ABH turns the matter it consumes into energy that's radiated outward.
Okay, so we're talking about how much bang for their buck these black holes are getting out of their cosmic meals, right?
Exactly.
Okay.
And the paper argues that because ABHs lack event horizons, matter can get closer to the singularity before it disappears. Think about the difference between burning wood in a fireplace and dropping it directly into a nuclear reactor.
Right.
You're going to get a lot more energy out of the reactor.
So ABHs are like those super efficient reactors, squeezing way more energy out of the matter they consume compared to regular black holes.
Exactly.
And that extra energy is what makes them such powerful quenchers.
Precisely. With more energy at their disposal, ABHs can heat up gas more effectively, drive those intense winds we talked about, and essentially put the brakes on star formation.
I'm starting to grasp the power of these ABHs.
Good.
And it's pretty awe-inspiring.
Yeah.
Even a little frightening.
It's powerful stuff.
But is there any evidence for them beyond those powerful winds?
Well,
I mean, this whole idea of a black hole without an event horizon seems so radical.
remember those observations of Sagittarius A?
Yeah.
The supermassive black hole?
At the center of our own Milky Way.
Yes, the paper suggests that it might actually be an ABH.
Whoa.
Yeah.
Our own galaxy could be harboring one of these exotic objects.
That's possible.
That's incredible. But we're still talking about supermassive ABHs.
Right.
What about those smaller ones? The stellar mass ABHs.
Yeah, any clues about them?
Yeah.
Yes, and this is where things get really interesting.
Okay.
The paper highlights observations of incredibly energetic emissions
Yeah.
coming from some stellar mass objects.
Okay.
It's possible these emissions are coming from those naked singularities we talked about earlier.
You're saying we might actually be catching glimpses of those exposed singularities, those fleeting moments when the core of a collapsing star is visible before the event horizon forms?
It's a tantalizing possibility.
Wow.
And while it's still very much in the realm of speculation, these observations offer a glimmer of hope
Okay.
that we might one day directly observe these mind-boggling phenomena.
This is all so much to process. I need a minute to wrap my head around it all.
Take your time.
ABH is potentially explaining both long-term and short-term quenching.
Yeah.
These powerful winds that could be signs of their transformation.
Well,
and
yeah.
maybe even glimpses of those naked singularities.
It's wild stuff.
It's like a whole new universe of possibilities is opening up.
I agree.
But I also have to ask.
Yeah.
How do scientists even begin to study something as elusive as an ABH?
That's a great question.
It feels like trying to catch a ghost.
It's a huge challenge, that's for sure.
Yeah.
We can't just point a telescope at the sky and expect to see an ABH glowing back at us.
Of course.
But remember, even though we can't directly observe ABHs, we can look for their fingerprints, the evidence they leave behind.
So it's like detective work, piecing together clues to track down an invisible suspect.
Exactly.
What are some of the clues scientists are focusing on?
Well, those powerful winds we keep talking about
Yeah.
are a major piece of the puzzle.
Okay.
Remember, the paper suggests those winds,
Right.
with their intense magnetic fields, could be a sign of an ABH transitioning into a regular black hole.
Okay.
And those magnetic fields leave a distinct signature that we can detect with radio telescopes.
So it's like using a metal detector to search for buried treasure.
Yes.
Even if we can't see the treasure chest directly,
Right.
the metal detector can pick up the signal from the metal.
Exactly. And as our telescopes become more sensitive,
Yeah.
we're getting better at picking up those faint signals
Okay.
from these powerful winds and jets.
So we're essentially eavesdropping on the conversations these ABHs are having with their surroundings.
That's a cool way to think about it.
That's a cool way to think about it.
Yeah.
But what about those naked singularities?
Yeah.
Any chance we could actually observe one of those?
That's the holy grail, but also the longest shot.
Okay.
Remember, those naked singularities are thought to be incredibly short-lived events,
Oh.
maybe lasting only a fraction of a second.
Right.
It would be like trying to photograph a lightning strike.
Okay.
You need to be in the right place at the right time
Right.
with incredibly fast equipment.
Yeah, but what if we got lucky?
Yeah.
What if we did manage to capture one of these events?
It would be revolutionary.
What would it tell us?
It would not only confirm the existence of ABHs,
Yeah.
but also give us an unprecedented glimpse into the physics of extreme gravity
Wow.
and the nature of singularities themselves.
So it would be like opening a window into the most extreme environments in the universe.
I think so.
Wow, just thinking about that possibility is mind-boggling.
It really is.
It really highlights how this ABH research is pushing the boundaries of what we thought we knew about black holes and the evolution of galaxies.
Absolutely. And that's what makes science so exciting.
I agree.
Sometimes the most unexpected discoveries come from challenging our assumptions.
Right.
And exploring ideas that seem at first to be outlandish or impossible.
Absolutely.
Who would have thought that black holes might not always have event horizons?
It's like that old saying, the more you learn, the more you realize you don't know.
Exactly.
This deep dive has definitely left me with more questions than answers, but in the best possible way.
Exactly. And the beauty of it is that each new question opens up a new avenue of exploration.
Okay.
Leading us deeper into the mysteries of the universe.
Well, I think we've reached the end of our journey into the world of ABHs and galaxy quenching.
It has been quite a journey.
It's been an incredible ride full of twists and turns and mind-bending concepts.
It really has.
I want to thank you for being such an awesome guide through this fascinating topic.
It's been my pleasure. And to our listener, thanks for joining us on this deep dive.
Keep looking up at the stars and never stop questioning what's out there.
Who knows what other amazing discoveries await us in the vast expanse of the cosmos?
Until next time, keep diving deep. Okay, so we were talking about studying these ABHs.
Right.
And it feels like, how do we even begin?
It's a huge challenge, yeah.
It feels like trying to catch a ghost.
You can't just point a telescope at the sky and expect to see an ABH glowing back at us.
Right, right.
But we can look for the evidence they leave behind.
They're fingerprints.
Yeah.
Okay, so what clues are scientists focusing on?
Well, those powerful winds.
Yeah, those crazy winds.
They're a major piece of the puzzle.
Okay.
Remember, the paper suggests that those winds, with their intense magnetic fields, could be a sign of an ABH transitioning into a regular black hole.
Right, right.
And those magnetic fields, they leave a distinct signature
Okay.
that we can detect with radio telescopes.
So it's like we're using a metal detector to
Yeah.
search for buried treasure.
Yeah,
Even if we can't see the treasure chest directly,
right.
the metal detector picks up on the signal from the metal.
Exactly. And as our telescopes get more sensitive,
Yeah.
we're getting better and better
Okay.
at picking up those faint signals from these powerful winds and jets.
So we're eavesdropping
Yes.
on the conversations that these ABHs are having
That's a great way to think about
with
it.
their surroundings.
Oh, yeah.
That is really cool.
It is.
Okay, but what about those naked singularities?
Yeah.
I mean, is there any chance?
It's the Holy Grail,
Really?
but also the longest shot.
Okay.
Remember, they're thought to be incredibly short-lived.
Yeah, fractions of a second. Right.
Maybe just a fraction of a second.
Right.
Like trying to photograph a lightning strike.
Right.
You need to be in the right place at the right time.
With incredibly fast equipment.
Exactly.
So what if we got lucky?
It would be revolutionary.
What would it tell us?
It would confirm the existence of ABHs,
Right.
but also give us an unprecedented glimpse
Okay.
into the physics of extreme gravity
Oh, wow.
and the nature of singularities themselves.
So it'd be like opening a window
I think so.
into the most extreme environments in the universe.
Yeah.
Wow, just thinking about that possibility is mind-boggling.
It really is.
It really highlights how this ABH research is pushing the boundaries of what we thought we knew
It is.
about black holes and the evolution of galaxies.
And that's what makes science so exciting.
I agree.
Sometimes the most unexpected discoveries come from challenging our assumptions,
Absolutely.
exploring ideas that seem at first impossible.
Right, like black holes without event horizons.
Yeah, who would have thought?
I know, it's like that old saying,
What's that?
the more you learn, the more you realize you don't know.
Exactly.
This deep dive has definitely left me with more questions than answers.
But that's a good thing.
In the best way possible, yeah.
And each new question just opens up a new avenue for exploration,
That's true.
leading us deeper into the mysteries of the universe.
Well, I think we've reached the end of our journey into the world of ABHs and galaxy quenching.
It's been a wild ride.
It's been incredible, I'll tell you.
It has.
Full of twists and turns and mind-bending concepts.
Absolutely.
I want to thank you for being such an awesome guide
It's been my pleasure.
through this fascinating topic.
And thanks to our listener for joining us on this deep dive.
Keep looking up at the stars and never stop questioning what's out there.
Who knows what other amazing discoveries await us?
In the vast expanse of the cosmos.
Until next time.
Keep diving deep.